In this talk, I'll explain how and why the universe is a computational system and what the amazing implications of this are for its fundamental nature and how it works. To begin, just take a look at the world around you. You think that you see a bright, colorful world full of physical objects that continually plays out the drama of daily life. However, cognitive science shows us without any doubt at all that the world we experience around us actually consists entirely of neural data in our brains. Sensory data is input into our brains through our eyes, ears, nose, mouth, and skin. And then our brain organizes it into data structures meaningful to our functioning and existence. The world we experience around us is entirely a simulation of the actual world running in our brains. Now, of course, there is a real external world outside our brains, but it's impossible for us to experience that directly. All we ever experience of it is the simulation our brains compute. But of course, every one of us assumes the world we experience is the real world as it actually is. But since every one of us and every individual of every species experiences that world differently, none can be correct. Every living being lives within its own simulation of reality, and every living being thinks its simulation is the real actual world. But this is simply not true. We experience the world as consisting of an empty space full of physical objects. But what we are really experiencing is data constructs being computed in our brains. This is easy to understand by analogy to virtual reality. All the actual data in a virtual reality exists as bits and bytes in the controller memory, which is not dimensional. But in the headset, all this data is projected into the semblance of a moving, three-dimensional world full of objects and actors. But the actual data of the virtual reality is data being computed in the controller memory. It's not actually objects in space. And it's exactly the same in our brains. All the actual data of our experience of reality is just data being computed in our brains. And then our brain projects it into the semblance of a three-dimensional space full of moving objects, just as a virtual reality becomes dimensional only in the headset display. Okay, so there's no doubt at all that every detail and aspect of the world as we experience it actually consists of data being computed in our brains. But what of the real world outside our brains? Is that data too, or is it physical objects in dimensional space, as we assume? All the evidence suggests it's just more data. How else could it be so convincingly simulated by data in our brains as a physical world if it didn't also consist entirely of data? If the data in our brains seems like a perfectly real physical world, then why couldn't the actual world also consist entirely of data? How else could it be so accurately and convincingly simulated as data if it wasn't actually data? Now, the insight that the universe consists entirely of data has profound consequences. First, the only way that data can change is to be computed. Thus, the universe must be computational. The universe is a computational system that continually recomputes itself in every moment. The universe is an enormous cosmic computer that continually recomputes its entire data state in every moment. This means that every process in the universe is effectively a running program that computes its own data state in interaction with all the other running programs that constitute its computational environment. And together, in interaction, the programs of all the processes in the universe compute the current data state of the entire universe. So even we are the programs of ourselves, continually recomputing the data of ourselves in interaction with the other running programs around us. Our program is enormously complex. It consists of all the myriad subroutines of every cell, organ, and system in our bodies, down to the interaction of our elementary particles. All these subroutines working together compute our organism and being in every moment of our existence. And since these computations involve quantum processes, and our control program has the ability to imagine, evaluate, and select among alternatives, Our computations are non-deterministic and there is room for free will. So we are the biological robots of ourselves, but we are free, autonomous robots capable of intelligent decision-making, and we remain fully human. Nevertheless, at the most elemental level, we consist entirely of data, as does everything in the entire universe. How this works is easy to understand because it changes nothing. Throughout history, science has progressively reduced everything to combinations of more and more elemental components. Materials were reduced to chemicals, chemicals to elements, elements to atoms, and finally atoms to particles. During this process, nothing changed in the objects themselves. They were just more deeply and completely understood. The discovery that we were made from elementary particles didn't change us in the least. Now science just needs to take one final step and realize that all elementary particles reduce to data. Each elementary particle is a different set of elemental data. With this, reduction of reality to the elemental components is complete. And again, nothing changes. Humans are still fully human, just as we were before. The fact that our elementary particles are actually data doesn't change us in the least. It just deepens our knowledge of ourselves. Now, the insight that the universe is computational and consists entirely of programs computing data also solves some major philosophical and scientific problems. For one thing, it immediately explains Wigner's The Unreasonable Effectiveness of Mathematics in the Natural Sciences. Until now, why mathematics is the best description of the universe has been a deep, unsolved mystery. But when we realize that the universe is computational, it's quite obvious that logic and mathematics will automatically provide the best possible description of a universe that is itself logico-mathematical. But even more profoundly, it solves the mystery of how and from where the laws of nature could control a universe that was thought to be physical. In a physical universe, there is no place for the laws of nature. Since they aren't physical objects, so where could they exist, and how could they control the universe? But in a computational universe, where everything is data, the data of the laws of nature automatically become just as real a part of the universe as the data they compute. The laws of nature are the virtual data that computes the observable data of the observable universe, and they're both equally real components of a computational universe. In addition, this computational model of the universe also leads naturally to the unification of relativity and quantum theory, as we'll see in subsequent deep reality talks. Okay, so if the universe is a computational system, what is its structure and how does it work? Since the universe is computational, there are basic similarities with how computers work, but there are some important differences as well. Any computational system must have data, a program that computes the data, and a processor that runs the program. Thus, the universe must have these three elements as well. There must be a program consisting of the data that encodes the fundamental laws of nature that's not directly observable. And there must be a processor that executes this code. Now, the cycling of this processor that runs the code that computes the universe will be the ultimate source of the passage of time. So the processor runs the program code which continually recomputes the data of the observable universe, which is the universe of science, consisting of particles and particulate structures. This is how the computational universe works in a nutshell, but there's more. The code data of the elemental program isn't directly observable. In other words, it's virtual data. Now, science has already discovered the realm of virtual data is the quantum vacuum. So it makes sense to assume that the quantum vacuum is the realm of all virtual data, and that the program code exists within the quantum vacuum as virtual data. Likewise, the processor isn't directly observable and must be an intrinsic attribute of the quantum vacuum itself. This means that the quantum vacuum is the non-dimensional computational space in which the observable universe is computed. In other words, the quantum vacuum is the original formless, dimensionless, virtual realm in which the observable universe is computed. So the observable universe must also exist within the quantum vacuum. Thus we can say that the data that constitutes the observable universe is the observable aspect of the quantum vacuum. Dimensional space-time and all elementary particles exist as an observable data structure we call the observable universe within the quantum vacuum. The observable universe is observable because its data structures interact. And the interactions of data structures are in fact what observations are. Otherwise, its data has the same status as the unobservable virtual program data. So we now have a picture of the hidden fundamental structure of all aspects of the entire universe. All that exists is the quantum vacuum, which is the entire universe, and all the data of the universe exists within the quantum vacuum. The observable universe of science exists within the quantum vacuum and consists of all actualized elementary particles and the structures they form. But in addition, the virtual data of the laws of nature also exists within the quantum vacuum. This includes what we can call the complete fine-tuning, which is all the fundamental constants, particle values, data types, logical operators, and whatever other virtual data is necessary to compute the entire observable universe. And in addition, the quantum vacuum is the processor that applies the program data to the observable data to continually recompute it. And the processor is the fundamental source of time in the universe. Each set of processor cycles computes all the observable data of the universe and produces a tick of the universal clock. The processor runs at an unimaginably rapid rate, far faster than the fastest particle interactions, because it's what computes them. The processor is the source of all happening, change, process, life, and time in the universe. It's what brings the universe and everything in it to life. And importantly, the processor cycle rate is what sets the speed of light. Recall in the first deep reality talk the fundamental principle that everything in the universe continually moves at the speed of light, either in time, space, or some combination of time and space. The processor cycle rate is now seen as the source of the speed of light that accounts for the continual velocity of everything in the universe. Every process in the universe is continually recomputed at the speed of light. Think of it this way. In every processor tick, a separate application of the processor computes each coherent process. Each processor application uses the same number of processor cycles to compute its process. If there is some velocity in space, some of those processor cycles are used to compute that velocity. Then any cycles left over are used to compute the internal evolution of the process. Now, the internal evolution of the process is how fast it changes in time as the processor ticks. It's the resulting clock time velocity of that process that depends on how much spatial velocity that process has. This is how the universal processor computes the principle that everything in the universe has a total space-time velocity equal to the speed of light. The speed of light emerges directly from the cycle rate of the universal processor that computes the universe. That's why the speed of light velocity applies to everything in the universe, because everything is computed by separate applications of a single universal processor at the speed of light. This is how the different clock time rates of relativity arise. The cycle rate of the universal processor is the same everywhere in the universe, because the speed of light is the same everywhere in the universe. But whenever there is spatial velocity, this same processor rate computes a slower clock time rate locally to keep the total space plus time velocity equal to the speed of light. This is how a single universal processor cycle rate computes all the different relativistic clock time rates in the universe. In essence, there are two distinct kinds of time, as I'll explain in an upcoming deep reality talk on time. Now that we understand the basic structure of our computational universe, we can proceed to explain how to accomplish the long-sought unification of relativity and quantum theory in Deep Reality Talk number 3. Stay tuned.